Okay, good afternoon. This is a quick review to give you a little bit of help on the homework assignment and probability if you need that. Originally, I had assigned questions 2, 11, and 35 out of the textbook. I have since decided that question 11 is not required. If you would like to do question 11, it can be worth up to 5 extra credit points, but it's not necessary that you do it. So today I'm just going to take a look at 2 and 35. You'll have to do a little bit of your own work to get the extra credit on number 11. So let's take a look at question number 2. This is dealing with probability. You don't really have to do much in the way of Excel calculations. For this, you are assuming that 3 coins are just dropped on the table. So the first thing you have to figure out is what the possible outcomes can be when you drop the 3 coins. So I've filled this part in for you. Now this is an ugly spreadsheet, but it gets us where we need to go. This is just numbering the possibilities so that I can help you with the explanation. So the possible outcomes, there's 8 possible outcomes. You can get all tails, 2 tails and a head, a tail, a head, a tail, a head, tail, 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 head, 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 tail, head, 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 tail, and all heads. So those are the combinations that you can get. And this is a very simple very simple explanation. But the calculation for that is actually 2 to the third, where 2 are the possibilities. You can either get a head or a tail, and 3 is the number of coins. So 2 to the third, which equals 8. So if you had, heads or tails and you were tossing 5 coins, the calculation will be 2 to the 5th. That's how many possible solutions you would have. Again, there's no calculations here. So that's what we have. This part in green is where you put in the probability. Now, this is easy because each outcome has a 1 in 8 chance of happening. Those of you that know statistics, we're just doing single throw of the coins, pick them up, another row of the coins. So 3 tails has a 1 out of 8 possibility. So you'll put the probability in here. They'll all be the same. I suggest you use decimals and not 1/8. So there's a hint on that. Now you have to look at a couple of different scenarios, and one is, in which scenario do you get exactly 2 heads? So that's a probability that you'll calculate here, where you get 2 heads. So in here, where do we get exactly 2 heads? So not here, not here, not here, not here. Here, here, and here. So there's 3 places where we get 2 heads. Same as if we wanted to look at 2 tails, here, here, and here. So there's 3 chances out of 8 to get exactly 2 heads. So that's your hint for that. You'll need a decimal to put in there. The second question is for B, which is letter D. Let B equal at most 1 head. So at most 1 head. So you're going to look through the possibilities again. And you don't want any more than 1 head, but that doesn't mean that you couldn't have less than 1 head. So here's a possibility here, here, here. And it looks like that's it, because the rest of them all have more than 1 head. So those are your possibilities there, 4. So the second one is, or the E is, let C be the event at least 2 heads. So at least 2 heads means here you have at least 2 heads, here at least 2, here at least 2, and here at least 2. Because you have 3, that's at least 2. So those are the events that you have. So you're going to fill in these calculations, and then over here are your probabilities. I don't care about your formatting. You can, and you don't have to use a formula for this because it's an easy thing. This is just kind of a review on probabilities. You can use a formula if you wanted to. You could do a count if formula. So count if, you know, is a tail, or count if, but you don't have to. You can just fill it in and give me a notation how you did it. Okay, so the next question is on mutually exclusive. So that's F. They want to know if events A, which is exactly 2 heads, and B, which is at most 1 head, are mutually exclusive. And mutually exclusive means that they cannot, it's impossible for them to happen at the same time. So for instance, when you toss one coin, it's impossible to have both a head and a tail at the same time. So that's what you're looking at. Are those events mutually exclusive? That means, can they not happen? So that's a different calculation. I'm not gonna go over that because it's not necessarily a difficult calculation. But you're trying to determine what the possibility of A or B. So just as a hint, that will be higher than either A or B, because either A or B can happen. The last one is A and C, are those mutually exclusive? And A is exactly 2 heads, and C is at least 2 heads. So because this is a short table, I'm not going to go through how you would do that, but numbering them will help you determine what your calculation should be. So hopefully that walks you through it. This is not complicated. Make sure that you answer the questions. So when you answer F, it says, are they mutually exclusive? I need an answer. So you can put that down here or whatever you want to do. Okay, so question 35. Let me take these out of here. Okay, so question 35. This is basically what it should look like. You're given this data right here. This is the census data. Everything that I put in green up here is a calculation. And they're simple calculations. You're just totaling the rows and the columns. Down here, this whole thing is calculations. So I didn't want to make the whole thing green. So I just put a note over here that the whole thing is a calculation. So let me take a look at your questions for that. They are, so let's take a look at this. So here in this particular spreadsheet, all you have are numbers. Numbers, not a high school degree up to an advanced degree. And here's your total. Oops, sorry. And then just to make your life easier, in case you don't know this, you can do a trace precedence and see what's leading up to that formula. You don't necessarily have to do it when you're doing a simple sum across the top or the bottom, but it's helpful when you have more complicated calculations. So here you're just doing summing. So the first question is, hang on. The probability that a person is divorced and has a bachelor's degree. So you have to do these probabilities here. So I left divorced, and these are the examples that we're doing. So down here, I'll show you what the things are. So you are just taking whatever the number divorced is and dividing it by whatever total you have here. So that's how you're getting these numbers, and you can figure out how to put the rest of them in. So I'm going to take this formula off. So the question is the probability that a person is divorced and has a bachelor's degree. Let's look at this. divorced with a high school degree, is this probability? So that would be the answer to that question. What are people, probability is someone who's divorced and has a high school degree. And that would just be that, and that's that calculation. This calculation, I have divorced with at least an associate's degree. So we look at the divorce line, at least an associate's is going to start here. So this is at least an associate's, this is at least an associate's, and this is at least an associate's. So here's the calculation. And what you're doing is summing these three together and dividing them by the total. So that's what you'll need to do for 35. You can maybe do a better job than I do on setting this up. I don't care how you do it. Give it to me in one spreadsheet. That would be really helpful rather than to have two. So one tab will have question 2, one will have question 35. And if you feel like doing 11, you can get extra credit. But these particular questions aren't particularly hard, but it's just kind of to give you an example on probability and statistics and how that works. So hopefully this was helpful to you. Let me know if you have any questions.